Welcome back, ladies and gentlemen. Today we're talking about identifying numbers written in scientific notation. So let's get right to it. First thing I want to be able to say is the key here is this word scientific. You're going to be using this more in science classes because there you're going to deal with really big numbers like the distance the Earth is in miles from the sun, or how far away Jupiter is from Mercury. These are really big numbers. You're also going to be dealing with really small numbers like the size of a bacteria compared to like an inch. How many bacteria are in an inch, or how big a bacteria is compared to an inch. Things like that. These are really little type of numbers. Think of Ant-Man. When he shrunk down, he went into the infinite microscopic space. Because no matter what, think about it, you can always get smaller. And technically, you can always get bigger. So he just kept getting smaller, even small enough to be atoms. Eventually, if you follow the comic books, they get there. Anyway, he gets into the quantum realm. We'll go ahead and skip forward and go get past that. Now, what we're talking about today is being able to identify if it is in scientific notation. So a couple of things that we're going to be looking at is what is scientific notation? What does it look like? What does it mean? And deciding whether or not what we see is in scientific notation. There's three parts to scientific notation. Part number one is going to be the factor. Oh, by the way, one of these parts should be easily recognized. So this part right here is always there. So this is our big X. We don't necessarily write with X's anymore. Hopefully we remember that. However, in this case, we're going to notice how there's always an X. That part is constant. It never changes. As long as you see the X, or technically EE, or there's a couple of things you can replace it with, but there's always something that separates. That's the constant. That's one of the three parts. It's something that divides our factors from our power of 10. And then there's always going to be something in here. So part one, part two, something is here, and part three. And I say something because on like a scientific notation calculator, you will see E, and that's used for scientific notation to replace the big X you'll be seeing on paper. Don't have to remember that, just a good heads up about how it works in the future. All right, if I confuse you, go back, listen a couple of times. I know I corrected myself a few times, so you should be able to get it cleared up pretty quickly. What we're doing is we're looking for a factor. So the rule of the factors is that it has to be greater than or equal to 1 and less than 10. So we have to ask ourselves, is 5.9 greater than 1 and less than 10? And if it's true, then it's written in scientific notation, at least as far as a factor. So is 5.9 greater than 1? Yes, check. So greater than 1? Yes. Is it less than 10? Sorry, greater than or equal to 1. Is it less than 10? Well, 5.9 is definitely less than 10, so check. So yes, 5.9 times 10 to the negative 6 is in scientific notation. If I can spell, there we go. This is why spell check was invented, by the way. All right. Now, I did kind of jump the gun. I forgot to tell you about or remind you of the third thing. The third thing is that is at a power of 10. So basically you have a base 10 to a power. Now, the power can be positive, the power can be negative, the power can be a fraction, the power can be whatever. As long as this is a 10 to a power, we're good. So power of 10? Question mark, and yes, it was. So we can say it is in scientific notation. All right, so we have a power of 10. We have something separating or multiplying it. And the last thing is this number greater than or equal to 1? And the answer is no. So instantly we can stop. We can say no, 0.9 times 10 to the 8th is not in scientific notation. Now there is a way that if it's not in scientific notation, to get it to be in scientific notation, and we'll talk about that a little bit later. So for now, we're just trying to see, is it written in proper scientific notation, or is it not in proper scientific notation? Because everything after the multiply, or as of the multiply, you're going to be able to recognize that right off the bat. It comes down to the factor. Is the factor greater or equal to 1 and less than 10? As long as it fits in that little window, it's going to be in scientific notation when you're multiplying by a power of 10. Now pause the video and copy what is on your screen into your notebook. Now that you're back, anytime you have to rewatch the video for clarity or to remember something, you need to write what you picked up into your notes. Use arrows, circles, shapes, pictures, whatever else you need to, but add it to your notes to make them yours. Last, ladies and gentlemen, you are in school. When you are learning, it's about understanding the process, not about finding an answer. We'll see you tomorrow.